Hello, my name is Venkat Pavanji. I am from Sri Venkateswara College of Engineering. Today's topic is blockchain as a security brick for software applications. Blockchain definition or conceptual. Blockchain is a paradigm shift in a way we approach designing economic systems involving multiple peers with divergent interests, but find it profitable to be part of the same system. The traits of such systems are decentralized, governed by rules without rulers, protocols instead of platforms. Trust is derived from the network, not from the hierarchy. Trustless transactions are secured by cryptography. Agenda. Blockchain definition. Blockchain or how to clone physical transaction to digital transaction. Blockchain and internet of value. Blockchain security of design. Blockchain security of internet of things. Physical transaction to digital transaction. Physical transaction. In physical transaction, it is easily verifiable. No need for a third party to validate the transaction. Mint does not have the money anymore, and SCMI has it in his hands. In digital transactions, what if the third party trusted duplicates the assets? He can even add his account whenever he wants. He can impose high commissions. What if the service is hacked? Service unavailable, SPOVF, and network problems. Blockchain definition technical. Append only distributed database ledger shared between multiple non trusting writers without the need for a trusted central authority. The data integrity of the ledger is guaranteed by the distributed consensus algorithm. Blockchain solution. It has three basic components. The first basic component is a data model that captures the content state of the ledger. Second, a language of transactions that changes the ledger state. Third, a protocol used to build consensus among participants around which transactions will be accepted and in what order by the ledger. Embedded security in blockchain design. Internet was designed without security as a priority, only a resilient network. Blockchain protocol was designed with security embedded in its core. BFT in practice identification and encrypted transactions. Internet security was implemented at an application protocol level, while the blockchain security is implemented at the low level protocol layer. Data security requirements, identification and authentication, cryptographic identity, data integrity, data confidentiality, data ownership and control. In data integrity, encrypted transactions coupled to common consensus and mechanism. In data confidentiality, zero knowledge proof and homomorphic encryption, data ownership and control in the distribution of the data. Blockchain security for Internet of Things. The blockchain character of Internet of Things networks makes it a good candidate for blockchain technology. Blockchain, which is most familiar for Bitcoin and Ethereum, offers an intriguing solution for Internet of Things security. Blockchain contains strong protection against data tampering, locking access to Internet of Things devices, and allowing compromised devices in an Internet of Things network to be shut down. Blockchain or how to clone physical transaction to digital transaction. In physical transaction, trusted is trusted to third party. What if the third party duplicates assets? He can even add account whenever he wants. He can request high fees. What if the service is hacked? Service unavailable. The end user does not have means to check in himself. In blockchain technology, the ledger is no longer owned by the single entity. Validation and verification of the ledger is no longer a monopoly. consensus rule guarantee for the security of the ledger. The end user can even guarantee the managing ledger, the purest version of the PC. Actions are incentivized to act ethically. Same rule, consensus algorithm, single source of truth. Big shift in business model designs for the blockchain security or blockchains. Business models are increasingly based on the reduction of intermediaries such as platform economy, which includes PayPal, Salesforce, and sharing economy, and P2P economy, which are the Bitcoin and Ethereum cryptocurrencies, and sharing economy such as e-commerce sites, Finding Circle, Airbnb, Uber, and Kickstarters, which are progressing rapidly from 2010 to 2015. Blockchain and Internet of Value. In the internet, innovation is the innovation in information transfer. In the internet, applications are streaming video and music, data sharing, and cloud computing. And the killer app for information sharing is email. And the network used for internet are ISPs and routers. Protocols and the protocols used in internet are TCP, IP, HTTP, DNS, and FTP, file transfer protocol. While as the blockchain innovation and value transfer. The blockchain application involves smart contracts, distributed computing, and tokenization. The killer apps are Bitcoin. The network used in blockchain are miners, nodes, staking, etc. The protocols for the blockchain are Bitcoin, Ethereum, IPFS, and Blockstacks. Blockchain is the last brick in the internet protocol that allowed the internet to move value between peers. Distributed database versus distributed ledger. In distributed database, nodes are distributed database trust each other and collaborate with each other to present a consistent secure truth of the rest of the world. It's all about the trust boundary. Nodes of the distributed ledger blockchain cannot trust each other, so must independently verify data they receive from each other and only share data they are happy to be broadly shared. In the blockchain technology, ICO DApp demo. DApp reference architecture. The DApp reference architecture has command line terminal, web browser, node console, and HTML, CSS, JavaScript, Web3GA, which are all the which are blockchains such as Ethereum Virtual Machine (EVM) and blockchain block 1, block 2, block 3, such as represented in the diagram, deployed by ICO contract, which is known as ICO DApp. The steps to creating the DCO app. Step 1, setting up the environment. Step 2, writing the smart contracts. Step 3, compiling and deploying, migrating the smart contracts. Step 4, testing the smart contracts. Step 5, creating the front end. Step 6, using the DApp. The example of or the front end of the DApp are should be known in the next image. This image shows the creating the front end of the DApp for simple basic structure of the DApp, and the interaction with the DApp, which this image represents a sample of the interaction of the DApp in the completed form. Thank you.